Welcome to this explainer. We are jumping right into some absolutely mind-bending research that Anthropic just published about autonomous AI systems. Today, we're going to explore exactly what this breakthrough means for the very future of engineering. For literally the entire history of AI, humans have been in the driver's seat for every single step of the development cycle. But recently, that dynamic has completely shifted. Anthropic is now delegating a rapidly growing share of AI development to the AI systems themselves. So we're going to look directly at their internal data to see what actually happens when the builders become the tools.
Let's kick things off with a figure that is it's staggering. 97%. In a recent entirely open-ended research project, Claude agents autonomously recovered 97% of a major AI safety performance gap. And to be clear, we are not talking about simple code auto-completion here. No way. We are talking about an AI generating its own hypotheses, executing validation scripts, analyzing its own failure modes, and iterating on its methodology, all without any human handholding.
All right, let's get into Section 1, the autonomous research breakthrough. To really grasp how massive this is, we have to look at the experiment Anthropic designed. They wanted to test a very specific problem. Can a weak model reliably supervise a stronger one? So they established a strict performance floor, which is basically how well the weak model does on its own, and a ceiling, which is how the strong model does with perfect data. Two highly skilled human researchers spent about a week on this problem, and they recovered just 23% of that gap. But then, they unleashed Claude-powered agents. Those agents worked for 800 cumulative hours and achieved near total convergence, recovering 97% of the gap. The humans essentially just pointed them in the right direction, and the agents designed every single experiment themselves.
But here's the real kicker, the cost. The total compute cost for that entire 800-hour autonomous agentic loop was just $18,000. Think about that. It establishes a completely new economic baseline for iterative research. At roughly $22.50 per hour of compute, you aren't paying for expensive human hours or massive new training architectures anymore. You are simply paying for inference and execution loops. The model's running its own scripts, parsing outputs, and adjusting parameters totally on its own. Moving right along to Section 2, the architecture of Claude code.
So how are they actually doing this magic? Well, the foundation is Anthropic's Claude code tool suite, and it relies heavily on something called the Model Context Protocol, or MCP. This is an open standard that allows Claude to connect directly to external data sources. Literally, it means Claude can access your terminal, run bash commands, interface with Git, and autonomously read and edit your codebase. It can even pull data from Jira, Slack, or Google Drive right there in the environment. It's like giving the AI a set of hands and a desk in your office.
And they scaled this capability up using agent teams. You don't just have one lonely AI working away. You have a lead agent acting as the project manager, coordinating work and assigning subtasks. Then you have background agents running parallel sessions simultaneously. That means they can tackle multiple parts of a massive code base at the exact same time. And using a custom SDK, engineers can build bespoke workflows with highly controlled tool access. It is essentially a fully parallel, self-managing workforce.
Which brings us to Section 3, Anthropic's internal engineering shift. This architecture isn't just theoretical. It has fundamentally rewired how Anthropic actually builds its own frontier models. You can clearly trace this rapid evolution on their internal timeline. Back in the early days, from 2021 to 2023, it was your standard human coding. Then we moved into the chatbot phase, where humans were basically pasting snippets back and forth. By 2025, coding agents started executing and editing files. And today we've reached the era of autonomous agents capable of delegating hours of work to other agents entirely on their own.
The result of all this is an explosive leap in productivity. By the second quarter of 2026, the typical Anthropic engineer was merging 8 times as much code per day as they were in 2024. 8 times. Now, Anthropic is quick to note that lines of code is an imperfect measure, right? It measures quantity over quality. So 8x might overstate the true productivity gain just a tiny bit. But the directional shift, it's absolutely undeniable. In fact, it's causing a massive surge globally, with platforms like GitHub genuinely straining under the capacity of billions of new AI-generated code commits.
So the crucial takeaway here is this: that 8x leap happens because engineers just aren't typing syntax anymore. As of May 2026, over 80% of the code merged into Anthropic's incredibly complex codebase is authored directly by Claude. The human role has been totally elevated. Engineers are now directing the architecture and rigorously reviewing the output, while Claude handles the vast majority of the actual implementation.
Let's unpack this further in Section 4, the economics of iteration.
Check out these experimental speedups on code optimization. Anthropic runs a standard test where they ask Claude to optimize a piece of training code to run as fast as humanly or computationally possible. In May 2025, Claude Opus 4 hit a respectable 3x speedup, but by April 2026, Claude Mythos Preview achieved an incredible 52x speedup. To put that into perspective, a highly skilled human researcher typically needs 4 to 8 solid hours just to reach a 4x speedup. So in these miniature, clear metric research loops, Claude went from being super helpful to being distinctly superhuman in less than 12 months.
Okay, Section 5, Upgrading the Engineering Workflow.
If you are a technical leader or engineer watching this explainer, listen closely, because the tools are ready right now, and you need to adjust your workflows immediately to keep pace. You must integrate AI reviewers directly into your CI/CD pipelines. Anthropic actually found that their automated Claude reviewer caught roughly a third of the bugs behind past incidents before they ever reached production. You also need to start treating AI-generated code as a first draft that demands architectural verification. And crucially, you have to shift your financial mindset. You need to budget for compute iteration cycles to solve problems rather than just budgeting for basic API calls.
Now, we do have to acknowledge that this transition is, honestly, it's psychologically jarring. There's a quote from an Anthropic engineer that just perfectly captures this disorientation. They point out that on the days where the autonomous systems work well, it's amazing. It's automated, it's better, and it's faster than humanly possible. But then, when things break at that immense scale, it leaves the human operator realizing they've completely lost the thread of what the system is even doing. We are managing systems that operate vastly faster than human comprehension.
So where does this all lead? Let's look at Section 6, the self-improving AI future.
Looking forward, Anthropic has laid out 3 objective scenarios for where this accelerating trend is taking us. Scenario 1. The trend stalls out into an S-curve, but current capabilities still diffuse widely, causing massive economic shifts. Scenario 2. AI labs see compounding efficiency gains, radically shrinking company sizes to the point where a 100-person company can easily do the work of 10,000. Or Scenario 3. AI systems become capable of full recursive self-improvement.
Let's really clearly define that third scenario, because it's the big one. Recursive self-improvement is the ultimate endpoint. It's a reality where an AI system is capable of fully autonomously designing, refining, and developing its very own successor. It completely removes humans from the development bottleneck, meaning the pace of progress becomes dictated purely by how much compute and electricity you have available to throw at it.
But you know, this hyper-efficiency, it absolutely comes with a societal cost. As another Anthropic employee noted about this automated future, traditional engineering relies heavily on a kind of gift economy of small favors. You ask a colleague for help, you create a little mutual debt, you build awareness and teamwork. Autonomous AI is instant and creates zero debt. But as the quote highlights, each of these is a lost bid for human collaboration. We are quite literally trading human connection for raw speed. Which leaves us with a profound, honestly kind of unsettling question to close out this explainer. In computing, Amdahl's law states that the overall pace of a system is capped by the parts of it that haven't sped up. Well, as Amdahl's law gets applied to humanity itself, what actually happens when our technological progress is no longer bottlenecked by human creativity and ingenuity, but simply by the amount of electricity and compute we can plug into the wall? Thank you so much for watching and keep learning.